Is this all right with the mic? Good? Okay. All right. Well, thank you guys all for coming out. I'd also like to thank Neil for allowing me to present here and being very supportive throughout all this. I'd like to say just that the information I'm going to be presenting today will be a little bit different and possibly contrary to things that you've heard in other places, so I'd just like to encourage everybody to keep an open mind. With that, I am going to get a little bit into some of the basic physiology and biochemistry, just a little bit to form some sort of baseline understanding to build off of for the nutrition recommendations. I'll try to simplify it as best as I can, and there's always time for questions after. I can always go back and go through things that you guys don't understand. I also like to say just please consult with your doctor before making any dietary changes or taking any new supplements, anything like that. All right, so I'm going to be talking about nutrition for autoimmune conditions. And I'd like to begin by talking about what autoimmune conditions actually are. So the mainstream theory for autoimmune conditions is that the immune system is overactive and is producing antibodies to our own tissue. So this would, there's certain triggers that are acknowledged. This would be things like stress, foods, different hormones, and these cause, according to the mainstream theory, cause the immune system to be attacking its own tissue. I'm going to be talking about a few different autoimmune conditions in specific today. One will be Hashimoto's, which is when the immune system is attacking the thyroid. Another will be multiple sclerosis, or MS, and this is the same condition with degeneration of the myelin sheaths of the nerves. And then also I will be talking about rheumatoid arthritis and ankylosing spondylitis, and that is destruction of the joints. So a couple of pieces of information that may serve to kind of contradict this mainstream theory of autoimmune conditions would be firstly, that women are much more likely than men to have autoimmune conditions. So as much as like 4 times as likely as men. So this would suggest that there's actually a hormonal role in the causality of the conditions. And I'd also like to point out that HIV, which is known as a virus that causes some, extreme immune suppression, generally shows many biomarkers, such as antibodies to your own tissue, that would suggest autoimmune conditions. By the mainstream theory, this is considered a medical paradox, but also kind of serves as contradictory information to this mainstream theory. So the alternative theory that we're going to be operating based on today is that the destruction of the tissue that's seen in autoimmune conditions is not due to destruction by the own immune system, but instead due to chronic inflammatory stress responses. In this situation, we can compare the immune system to the cleanup crew, where the antibodies, rather than destroying the tissue, are actually only there to clean up the dead tissue after it's been destroyed. A little bit of support for this theory. This would include, there's a study on rats, or actually on rabbits, where they removed a piece of cartilage, damaged the cartilage, and then put this piece of cartilage back in. When this happened, the rats started producing antibodies to this cartilage. When they did the same procedure without damaging the cartilage, there was no antibodies produced. So this is suggesting that the antibodies are only occurring in response to the damaged tissue. There's also traumatic brain injury, and oftentimes in traumatic brain injury, antibodies are produced with the onset of the healing process. So this is suggesting that when the dead cells from the traumatic brain injury are being cleared out, this is when the antibodies are being produced. So in both of these cases, this would suggest that the antibodies are not actually destroying any of the tissue, but are there to clean up the dead tissue. So the current treatment for autoimmune conditions, there are 2 main routes, and one is symptom management. The other one is immunosuppression. So oftentimes when symptom management is not feasible, such as in rheumatoid arthritis or ankylosing spondylitis, immunosuppression is the route of prescription medication, where either cortisone injections or Humira are both commonly prescribed in order to suppress the immune system and with the goal of suppressing the immune response. The other route of symptom management also is commonly prescribed when available, for example in Hashimoto's. In this case, they will prescribe thyroid hormone as a supply for the decrease in thyroid hormone that's being produced from the supposed immune attack on the thyroid. In both of these situations, there are a couple of issues. The first one is that the underlying cause for the autoimmune condition is not addressed. So assuming that the underlying cause is an inflammatory stress response chronically over time, but neither of these routes of treatment are addressing this underlying cause. Now, this underlying cause would be the same responses that are seen in other degenerative diseases. This includes things such as other autoimmune diseases, cancer, osteoporosis, Parkinson's, Alzheimer's. All of these conditions are the same chronic inflammatory stress responses are seen. So by not addressing these responses, you're also increasing your risk for these other conditions. There are also direct effects of immune suppression, which can be damaging, at the very least susceptibility to infection, but also susceptibility to those chronic diseases is increased due to the immunosuppression. Just another little piece of evidence that supports that all of these degenerative diseases are occurring by the same inflammatory response. Patients who have advanced MS, which is multiple sclerosis, another autoimmune condition, they have the same systemic biomarkers as stage 3 cancer, which is basically suggesting that the same underlying process is causing both of these conditions. So before I get into the actual nutrition recommendations, I'd like to talk a little bit about why nutrition would make a difference. And to do that, we have to talk about the causes of these conditions. So looking at the main cause of inflammation, inflammation occurs when the energy demand is greater than the energy response. So energy demands would be things like stressors. So that includes any sort of psychological stress, it includes exercise, it includes just daily physiological functions that we need in order to stay alive, in order to survive. And when our energy supply, which is the energy that we're able to produce from the food that we're eating, when that is not adequate, this is what causes inflammation to occur. So now for a diagram. In order to talk about an energy supply, we have to talk about metabolism. So metabolism is the process and the rate at which we are able to produce energy. So to put this very simply, up here at the very top we have glucose. Glucose then follows down this path into what is called glycolysis and becomes pyruvate. This part is not as important because it has to happen either way, but here's where the important part comes in. Pyruvate can either be converted into lactate or it can continue on to the citric acid cycle and the electron transport chain. Now, when pyruvate is converted to lactate, the energy production process essentially stops there. As opposed to if pyruvate continues down through the citric acid cycle and electron transport chain, more energy is able to be produced. To put this in the context of energy supply, going the longer route through the citric acid cycle and the electron transport chain, this would produce more energy, leaving greater energy supply and effectively decreasing inflammation. We'll come back to a couple of those different components later. So to put this into a little bit better of context, we can look at the reason for why we need to be able to decrease or increase our metabolism. We're looking at these guys. They were often faced with different situations that we might not face in our environment today, such as famine and abundance. So in the situation of famine, the metabolism would slow down. This is because there's not adequate food supply, so we have to supply our own energy using our own tissue. So this includes the breakdown of fat tissue or fat oxidation, and also the breakdown of our other muscle tissue. So in this case, the metabolism would be suppressed in order to encourage our survival. And these sorts of mechanisms would be encouraged by things such as fat oxidation, increased stress, and increased exercise. All three of these would be things that you would see in the situation of a famine, so they all encourage the slowing of metabolism to encourage survival. In the situation of abundance, this is when nutrient-rich, energy-dense, or glucose-dense foods are available. This is a situation where the metabolism can increase because there is abundant energy available. In this situation, there's a lack of stress, and there's not the complication of excessive exercise due to the abundant energy sources that are available. So our body is then able to increase our metabolism, which is the driver of all of our body's functions. This includes the digestive system, the reproductive system, the nervous system. So basically everything that requires energy, which is our entire body, is able to occur at an increased rate, and a more optimal rate when we have an abundance of food and a lack of stress. Another little diagram. This one looks a lot more complex than it is. This is called the Randle cycle. So here, this is pyruvate, which came from the glucose oxidation earlier. Now pyruvate, when it does go into that citric acid cycle or the Krebs cycle, this is where energy is produced. When glucose does this, it also inhibits the free fatty acids from going into the Krebs cycle. So to put it simply, when the free fatty acids go into the Krebs cycle, this inhibits glucose from going in and vice versa. This would support the difference in metabolisms during famine and abundance. During abundance, glucose metabolism is able to occur because of abundant sources of energy, and during famine, we would only have our own fat stores as energy and a small amount of muscle tissue. So in this case, the free fatty acids would be oxidized and glucose would not be oxidized. Final part before getting into the actual nutrition recommendations is the hormones. We have to talk about these hormones because the hormones are basically the signal regulators of the metabolism. These are what signal your metabolism to either slow down or increase, and because of this, you can consider these hormones as far as stress or anti-stress hormones. The stress hormones would be the hormones that are decreasing the metabolism. These would be things such as cortisol and estrogen. These are also known as the catabolic hormones. So these hormones are produced and start breaking down your own tissue for energy, as would happen in a famine. These also cause the increases of prolactin and serotonin. All of these hormones are directly implicated in autoimmune conditions and also the other chronic degenerative conditions such as cancer, osteoporosis, Alzheimer's, etc. And there are then the anti-stress or protective hormones. So this would be first and foremost thyroid. And thyroid is the driver of the metabolism. So when your thyroid hormone is increased, this is increasing the metabolism throughout your whole body. As you can see on the slide there, it talks about some of those different functions: digestive, immune function, reproductive function. Basically, all these things are functioning optimally with the higher metabolism, and these things can all occur with higher thyroid hormone. Pregnenolone, progesterone, and DHEA are a few other protective anti-stress hormones, and these all act to counteract the stress hormones: cortisol, estrogen, prolactin, serotonin. All right, so with that, we can start talking about the actual foods. We start by talking about polyunsaturated fats, and these are fats found in the liquid oils except for olive oil. So this would be any canola, cottonseed, flaxseed oils, any oils like that. It also includes nuts and seeds and fats from chicken, fish, and pork. So these polyunsaturated fats are shown to trigger inflammation by slowing the metabolism, by moving towards that famine, the famine metabolism. It does this by a few different mechanisms, one of which is by inhibiting the thyroid function. So this occurs in 3 different spots. It occurs when the thyroid hormone is released from the thyroid. It also is inhibited during the transport of the thyroid hormone from the thyroid to the target cell, and it also inhibits the action of the thyroid hormone in the target cell. So all these act to help decrease the metabolism. These polyunsaturated fats also increase all of these stress hormones that we talked about just earlier: cortisol, estrogen, prolactin, and serotonin. And they've also been shown to decrease cytochrome oxidase activity by up to 90%. So cytochrome C oxidase activity is the third blob on that chain right there, and that's the electron transport chain that we were talking about earlier. So this is where a large amount of our energy is produced, and cytochrome oxidase is just one piece of that pathway, but it is inhibited up to 90% from these polyunsaturated fats. Polyunsaturated fats are also so strongly anti-metabolic or metabolically suppressing and immunosuppressive that they've been used for organ transplants, where the recipient of the organs have actually been treated with polyunsaturated fats so that they would better accept the organ donations. Polyunsaturated fats have also been shown to increase intestinal permeability. I'll talk about that a little bit later, but that basically allows small particles that are in your gut to get into your bloodstream. So these are particles that aren't necessarily supposed to be getting into your bloodstream, but polyunsaturated fats increase the permeability, so increase the ability for that to happen. They are also implicated in many of the degenerative diseases, such as cancer, where increased amounts of the polyunsaturated fats have been associated with increased amounts of these degenerative diseases. And in many studies with these polyunsaturated fats, they find that when rats are found to be deficient in the polyunsaturated fats by removing the polyunsaturated fats from the diet, they have an extremely high metabolism, and they are also extremely difficult to kill by normal means. That would suggest that a reduction in these polyunsaturated fats would be protective. So in contrast to the polyunsaturated fats, we have the saturated fats. These would be fats such as butter, coconut oil, fats from ruminant animals. These are animals such as cows, bison, lamb, sheep. So these fats are protective against polyunsaturated fats and oppose them in many of their actions. They also help to inhibit bacterial growth. They have many antimicrobial and antifungal properties. We'll get to bacterial growth a little bit later when we start talking about starch. They've also been studied more recently as possible cures for different liver diseases. Now on the starch. So starch we're talking about foods such as grains, beans, any sort of indigestible fibers from vegetables, seeds, possibly nuts as well, and other flours and processed grains. So these starches generally reach your large intestine where your bacteria are housed without being digested fully. So once your bacteria are able to then digest these starches, they release what's called endotoxin, or liver polysaccharide. Just for a little bit of context, an excess of endotoxin is also called septicemia, and this is the third leading cause of death in emergency rooms. Kind of puts into context how actually strongly inflammatory these molecules are. And they are oftentimes used as well in studies for killing the animals. As for starch's effect on blood sugar, starch is made up completely of glucose. There's no fructose in any starch. So this causes a large rush of blood sugar, or of sugar to enter into the bloodstream, which causes a large amount of insulin to be released to reduce this blood sugar. This is what's known as the blood sugar crash. And this crash can be pretty strongly inflammatory as well. This causes the release of the stress hormones such as cortisol to break down other tissues so that way blood sugar can be replenished. So this is something that we'd be looking to counteract. As far as cholesterol goes, this would be found in foods such as eggs, also the fats from these same ruminant animals, and you can also make cholesterol from sugar if you're consuming an adequate amount of sugar. And contrary to what is most often talked about when cholesterol comes up, cholesterol is actually one of the most basic all-purpose protective molecules that we have in our body. Functions in all sorts of very basic ways, such as cell division, DNA replication, also for nerve function and learning. It's extremely important for our brain. Our brain only weighs about 2 to 3% of our total body weight, but actually uses as much as 25% of our total cholesterol. Cholesterol is also a precursor for all of the protective steroids that we talked about earlier, the pregnenolone, progesterone, and DHEA, and is tied very closely to immune function. So cholesterol has been shown to be able to deactivate viruses, and LDL specifically has been shown to counteract the effects of endotoxin. Just going along that vein of LDL and HDL, HDL is generally produced in response to many of the stressors. So while HDL is generally considered the good cholesterol, it is actually generally produced in response to a lot of the stressors such as alcohol, radiation, polyunsaturated fats, excessive exercise. So having increased amounts of HDL is generally more representative of a very stressful situation and would also therefore encourage the famine metabolism. This study over here, if you pay attention mainly to that dark blue line, this study, they looked at 164 different countries and their total cholesterol levels. And that blue line right there is all-cause mortality. So that point, that curve at the very bottom, is actually a level of 200 to 240 cholesterol. So it means that the lowest incidences of all-cause mortality of dying from any reason was for people at a cholesterol level between 200 and 240. There have been several other studies that support this. The Framingham study, for example, suggested that in patients above the age of 50, patients with lower cholesterol had greater incidences of Alzheimer's. And surprisingly, low amounts of cholesterol can actually be associated with autoimmune symptoms. On to sugar. So I'm talking more about the fruit sugars, honey, and white sugar. I'm not talking about the sugar that, I'm not talking about donuts, pastries, cookies, and those kinds of processed foods. And not because the sugar is any different, but because of the other components that generally come with those foods. So that would include a lot of the starches and polyunsaturated fats. It would also include a lot of artificial chemicals and preservatives. But sugar on its own can be extremely protective. One of the ways that this happens is by regulating the blood sugar. So by being able to maintain proper blood sugar, you're able to maintain proper thyroid function, which is, remember, the regulator of the overall metabolism. So sugar is required in order to convert the inactive thyroid T4 hormone into active T3 hormone. So this is basically the driver of the metabolism. Sugar is also needed to produce the anti-stress hormones, such as pregnenolone, progesterone, and DHEA. And increasing the amount of sugar in the diet, in many studies, such as certain studies on rats, they found that this can increase the metabolic rate as much as 50%. What this basically means is by feeding these rats higher amounts of sucrose, which is just table sugar, they were able to eat 50% more calories and maintain their weight. Sugar is also excess sugar or adequate amounts of sugar can be used to convert cholesterol into the steroid hormones and to be able to produce more endogenous cholesterol. Now to talk a little bit about fructose. So fructose, contrary to glucose, you can see here the top bar is the glucose and the bottom one is the fructose. Fructose raises blood sugar much less and actually has a somewhat suppressive insulin effect. So when these are combined in the form of white sugar, honey, any sort of natural sugar such as fruits or fruit juices, when these are combined together, it suppresses the insulin response, it suppresses the insulin spike that you would see from starch, such as glucose alone. And part of this is because fructose is able to increase the rate of carbohydrate oxidation by up to 20%. The way that this is done is by increasing the activity of the enzyme pyruvate dehydrogenase and also by increasing cytochrome oxidase. So cytochrome oxidase is one that was inhibited right here from polyunsaturated fats, and pyruvate dehydrogenase is right here. So this is what converts pyruvate into acetyl-CoA to continue to be oxidized to produce more energy as opposed to being converted into lactate. Sugar has also been shown to pretty strongly protect against a stress response, such as when the catabolic hormones, such as cortisol and estrogen, are produced. Sugar can very strongly antagonize this, especially by raising the blood sugar. And sugar has been shown to be protective against the endotoxin that we talked about earlier that was produced from starch digestion. Also been protective against alcohol, where it has been shown to increase the metabolism of alcohol by up to 2 times. And sugar has also has like very strong healing and protective properties, and has been used to pack battle wounds or in open heart surgeries even when other means were not available in order to speed the healing and protect against any sort of infection. Can't talk about sugar without diabetes. I know that would be probably one of the first questions that would come up. So I have a picture of the Randle cycle again, and we'll get to that in a second. But so basically, diabetes, one of the telltale signs is a damage to the beta cells of the pancreas, and these are the ones that produce insulin. Sugar has actually been shown to help regenerate these beta cells, and we'll get into why in a second, because when we look at the Randle cycle, we can see that when fatty acids are being oxidized as fuel, this would be what's happening during the famine or slower metabolism. This is blocking glucose from entering the cycle. So this would basically suggest that the oxidation of free fatty acids is what is stopping glucose from being used for energy. When glucose is not being used for energy, our body senses that and then increases our blood sugar in response in order to try to encourage glucose to be produced. Insulin is what shuttles this glucose into the cell to be oxidized. When the glucose isn't being oxidized, the insulin signal is not reaching its target. So you can basically think of diabetes as these free fatty acids blocking the oxidation of glucose over an extended chronic period of time. All right, so the calcium-phosphorus ratio. Calcium is basically a high level of calcium in relation to phosphorus is found in foods such as dairy and well-cooked greens such as spinach, collard greens, kale. So these minerals oppose each other in the body, and increased levels of phosphorus to calcium have been implicated in many of the degenerative diseases such as cancer, autoimmune conditions. And elevated phosphorus has also been shown to increase what's called parathyroid hormone, which has to do with maintaining calcium and phosphorus balance. Increased levels of parathyroid hormone have been directly implicated in diabetes as well. Salt has been shown to directly stimulate the metabolism. Part of this is done by opposing those stress hormones. And one of the more common objections that comes up with salt is high blood pressure and cardiovascular disease. I'd just like to point out right here, this study was looking at salt intakes and cardiovascular disease events and death from these events. So when you look at that dark line that's on the very bottom of both of those graphs, that is the highest amount of sodium intake. So this was a sodium intake of 4 to 6,000 milligrams. To put that into context, the recommended daily value from the USDA is around 2,300 milligrams per day. So this is significantly more, at least double. And that dark line is showing that the lowest incidence of cardiovascular disease events and death from these events occurred in this group of people. As far as protein goes, this would be from foods such as dairy, gelatinous meats, seafood, and also muscle meats and fish, like steak. A general recommendation for protein for an average adult would be between 80 and 100 grams per day. So obviously changes based on body weight and other requirements. But a couple of the reasons why I've ordered these protein sources in this way is part of the reasons for this calcium to phosphorus ratio, where many of the muscle meats have much higher ratios of calcium to phosphorus as opposed to something like dairy. There's also differences in amino acid ratios that help that would activate the metabolism with excess amounts of muscle meats. This includes fish as well. Just a few different supplements that may be helpful for autoimmune conditions and been shown to have some benefit. First would be aspirin and vitamin K2. So aspirin is actually what could be called a functional estrogen antagonist, which basically means that all of the actions that estrogen, one of the stress hormones, has, aspirin opposes them. So this would basically suggest that aspirin is pretty strongly anti-stress. It also inhibits the release of these free fatty acids, which we were talking about in this random cycle. So this would allow more efficient oxidation of glucose, because they would not be blocked by the oxidation of the free fatty acids. So this would stimulate metabolism as well. Dosages of up to 3 grams per day have been shown to be helpful for autoimmune conditions. A few of the B vitamins I'm going to touch on, all of them have been shown to be helpful, but specifically niacinamide and biotin have been shown to have great relief in symptoms. Niacinamide acts similarly to aspirin in that it inhibits the free fatty acids from being released and simulates glucose oxidation in the same random cycle. It also improves what's called the NAD to NADH ratio. And this ratio is a systemic biomarker that is implicated very strongly in cancers and various different degenerative diseases. And again, it's around 3 grams per day has been shown to be helpful. Biotin, this is much more up-and-coming and interesting B vitamin that they've been studying with autoimmune conditions. There's actually trials right now with multiple sclerosis, MS, where they've been using up to 300 milligrams per day of biotin. This is very high dose biotin. And they've actually been able to stop MS in its tracks after about 6 months or so. Caffeine, coffee, is generally known to very strongly stimulate the metabolism. So it also inhibits the release of the free fatty acids, similar to aspirin and niacinamide. However, because of the strong metabolic stimulation, it's important to consume coffee or caffeine with a meal, or at least some source of sugar. If not, because you're increasing your oxidation or usage of sugar, your blood sugar will drop if you consume caffeine without any other sources of sugar. So this causes, again, the release of those stress hormones, cortisol, estrogen, serotonin, prolactin, and cause the catabolism or breakdown of your own tissue to be used for energy, as opposed to consuming the caffeine with some sort of other fuel source, such as sugar or a meal. This would inhibit these stress hormones from being released. Also, coffee and caffeine have been shown in many studies to decrease the risk of all sorts of degenerative diseases. There's a few more supplements that I'm not going to touch on right now, but it may be worth looking into in the context of an autoimmune condition. The first is methylene blue, and methylene blue has a very similar action to caffeine. There are also the fat-soluble vitamins, A, D, E, and K, magnesium, and the tetracycline antibiotics. So just a couple final thoughts. I'd like to put into context that when increasing your metabolism, this also increases your need for nutrients to support the production of energy. So this would mean that when making any of these dietary changes or using any of these supplements to increase the metabolism, to encourage the use of whole foods in order to maintain enough nutrient density. Otherwise, increasing metabolism can sometimes cause nutrient deficiencies. I'd also like to encourage everyone to experiment and try things and see what works for them and see if they notice any differences, but also before doing any sort of that experimentation, especially with the supplements, to consult your doctor first. That's it. Thank you very much.